Yes, sir.
Okay, so I'm going to start it. So we are discussing about different pattern of many different types of lighting. Okay, so now that's from the continuations. Okay, so different types of system of lighting. Okay, direct lighting, indirect lighting scheme. Okay, then configurations. Then we are going to discuss about the basic calculations. Okay, suppose you are suppose you are in a auditorium or you are in a stadium. If you want to design that lighting, so we have to maintain some, we have to design the entire premises with having some uh, analytical methods, some calculations are needed. Okay, so based on that we can design it. Okay, so so we know that illuminations are required in different purposes. Okay, so what are the purpose you can understand. Okay, so there are so where we can see different steady movements. Okay, to understand the steady movements, what is illumination basically? Basically, we know that light energy is there. If it is reflecting from any of the particle, only we can visualize the objects. Okay, so if you want to see in very prominent manner, so what we need to do, that reflections or reflection, that should be very prominent way, and it's totally based on the intensity. Okay, so where we can see the steady movements. Okay, so steady movement towards the higher intensities of the artificial illuminations. Okay, during the last few decades. Okay, so based on the intensity, so which situations the intensity for that OT theater of the light. Okay, for that point, if we are having some point objects. Okay, so the intensity definitely more, okay, than your domestic lighting. Okay, so based on the purpose, we are changing the intensity, where it is higher intensities are required or lower intensities are required, and where the average intensities are required. Okay, so if we are going to see the movie in a multiplex. Okay, so if that intensity is very high, so it's not the ISO thing. Okay, so that's why we have to decide it as per the requirement. Okay, so that intensities and how to calculate the intensity. Okay, so how many lamps are required for that, getting that average or optimum intensities. Okay, so you know that's a diffused lighting. Okay, the human eyes propose the tremendous power of the accommodations can comfortably. Main important thing is that comfortably within an enormous range of illuminations. That should be our target. For example, a full moon. Okay, the sun provides that 120,000 lumen per meter square. Okay, so it's a irradiance. Okay, 120,000 lumen per meter square. So diffuse daylight on a window is order of 600 lumen per meter square. So okay, so that value are less. Okay, 600 lumen per meter square. Okay, so that's why we are using glass window. Okay, the full moon night. Okay, full moon night, so it gives that 0.1 to 0.3 lumen per meter square. For reading, the usually 20 to 30 lumen per meter square is generally considered the sufficient. Okay, so as per our visualizations, how much lumen per meter square? That is 120 to 30 lumen per meter square. But if you are in OT, okay, if you are in OT, so it's required 160,000 lumen per meter square. Okay, so different single dome, multiple domes are there. Okay, so based on that, so you can understand that how much intensities are there. Okay, throughout the daylight illuminations is much higher. Okay, some persons can read without the mainstream illuminations are slow, that 30 lumen per meter square. Because of this, the difficulty to lay down the definite values of the illumination for the various purpose, but following summary will be found useful. So there is some tables are given. Okay, so from the table we can understand for the which purpose of work how many lumen per meter squares are required. Okay, the precision work means if you are very precision work means very smooth. Okay, so if you want to do very smooth work, okay, so precision work, display, okay, all those things task require rapid discrimination. So minimum 500 lumen per meter square is required. It's above 500 lumen per meter square. Okay, so minimum 500. Extra fine machine work around needles, okay, screwing machines, okay, so all those things that fine, okay, so it's normally required 500, okay, minimum 500, and fine, then it's up to having the lower contrast maximum 200 to 500, okay, so it's starting from extra fine machine, so moderately it's required. Then proofreading, drawing, okay, so for the skill bench, okay, skill bench work, it is 100 to 200 lumen per meter square. Drawing office, okay, office art exhibition usual reading, that is 60 to 100. Okay, so usual drill, okay, drill machines and simple nature not, then fine details. So gradually you can see that values are decreasing based on that work. Okay, based on that application. So here you can see for hospital ward, ER, the railway platform, corridor. So it is 5 to 10 lumen per meter square. Okay, so you can see the emergency precision of the work. Okay, the efficacy of the work, the lumen per meter square also varying. Okay, if it's more means you can understand there is a more cost. Okay, more lumen per meter square means more cost are there. Okay, so definitely for railway station you not required for that flood lighting. Okay, so flood lighting means for the stadium, so it's a costly. Okay, so requirement based on the requirement, so for hospital ward and railway stations moderate lighting is required. Okay, not so much bright and not so much dim or dark. Okay, so based on that you can optimize the lighting. Okay, so it's normally 5 to 10, okay, lumen per meter square. Okay, space slash height ratio. Okay, space and height ratio for how it's spreading. Okay, that light is how it is spreading. Okay, so for getting we have to know that ratio. Horizontal distance between two lamp. Okay, that is required for our next calculations. Okay, horizontal distance between two lamps and mounting height of the lamps. Okay, so you can understand in the distance between two consecutive lamp. Okay, and the mounting means how far it is installed from your ground level. Okay, this ratio, okay, this ratio depends on, this ratio is depends on the nature of the polar curve. Okay, the nature of the polar curve of the lamp when we used along is a reflector. I have missed one topic. Okay, so that's the polar curve. Okay, that I will discuss. Okay, so what do you mean by the polar curve? Okay, so you know that diffusions. Okay, so polarizations and diffusions. Okay, in your class 2 level. So light having another two properties. Okay, so that is called that polarizations and diffusions. Okay, so that hello. So another two properties are the normal, excluding the normal properties. Okay, so in that case, what we are considering that it's based on that how the lights are spreading. Okay, so you know that in your class 2 level that if you are considering that light sources, okay, how they are intercepting. Okay, suppose to, you know that you are having one car, okay, car having two lights inside, just front lights, I'm talking about the front light. So how you are nullifying that dark points. Okay, so how far it is observing, so it's totally based on that intensity of that or the light as well as the how do you diffused. Okay, so from that polarization curve we can get some test data. Okay, suppose in increasing or decreasing the intensity how it is spreading, and we are plotting them, plotting those values, and we will get some curve. Okay, polarization curve. Okay, based on that we can define. Suppose you know that in magnetization we are having BH loop. Okay, we are having some BH loop. Based on that loop, what we are doing? Okay, based on that loop, what we are doing, we can decide. Okay, so we can decide how much magnetic intensity you have based on your material, which magnetic material you are using. Okay, and based on that, how much energy can be wasted. You know that that oven. Okay, so sometimes what happen, that huge magnetic energy also required for the different purpose, that BH loop. Okay, how much area it can spend. Okay, so that much amount of cost of loss is there, and that loss may cause for energy enormous heat energy. Okay, so how it will be decided. Okay, so definitely, so based on the material and the properties. Okay, so similarly we are changing that magnetic intensity, and we are getting those value. Okay, BH. Okay, H is the intensity, H is the flux density. Okay, so like that we are plotting over there. Similar thing happened for the polar curve also, changing of that intensity of the light, and we are getting the data how better it is diffused. Okay, we are getting some polar type of charts. Okay, so that's why it is called the polar curve. So that portion I missed, I will discuss. Okay, so when used the reflectors. Okay, normal lamps, but it was written ratio depends on the nature of the polar curve of a lamp. Okay, and when used along with the reflectors. Okay, the reflectors are there, so based on that you can decide that value. A reflector has the tremendous influence on the shape of the polar curve of the lamps. Okay, so it having influences, hence the value of the space per height ratio in fact depends on entirely on the types of the reflector used. Which type of reflectors are used, based on that you are selecting that value. For obtaining uniform illuminations on the working plane, it is essential to choose the correct value of the ratio. Okay, so these all are the very important parameters. Okay, to find out that in uniform distributions of that light, as well as how far it is going to illuminate it, and how to calculate them. That's very important. So first option is the space per height ratio. Okay, so what is that? Horizontal distance between two lamps, and mounting ratio between the mounting height of the lamps, how far it is situated from your base level. Okay, then important points, the design of lighting schemes by the layouts. Okay, what are the different types of layouts? So lighting schemes are, which are the lighting scheme provide the adequate illuminations. Okay, when you are going to find out that, then avoid the glare and the hard shadows. Okay, so how much glares are there, you should avoid them. Okay, provides the sufficiently uniform distribution of light all over the working plane. Okay, so how uniform distributed the lights over the working plane means the plane is there, based on the plane how it is distributed. Okay, before explaining the method, determine the number. Okay, what is the basic one? Number, size, and proper arrangement of the lamp. Okay, that's very important. Number, size, and proper arrangement. Okay, that we need to know. Okay, in order to produce a given uniform illuminations. Okay, uniform illuminations over certain area. Okay, let us first consider the following two factors, which are the importance in such calculations. So we have to know some calculations. Okay, to understand what formulas are going to use for that methods. Okay, first one factor is there that we need to know, that is utilization factor. Okay, utilization factor or coefficient of utilizations. Okay, that is neta n efficiency, that thing. Okay, not efficiency, that we need to know that factor. Okay, before going to details calculations, what is this? Okay, it's a ratio. Okay, it's a ratio of the lumen actually receive the particular surface on the total lumens emitted by a luminous source. Okay, the source is there, based on that we are getting that one. Okay, n equals to how much value lumen actually receive from the working plane. Okay, lumens actually receive on the working plane by the lumens emitted by the light source. Okay, that emissions are there, light emissions there from the source, and how much it is received, the ratio in between. The value of this factor varies widely. The value varies widely and depends on the following factors. What are the normal important factors? The type of lighting system, whether direct or indirect. Number one, type of the mounting heights of the fittings, means light holders. Okay, color and the surface of the wall and ceiling means where it is mounted, color of the light, where it is mounted, it is surface on the wall, means wall mounted or ceiling mounted. Based on that, the sum extent on the shape and dimensions of the room. So okay, so you are fixing up a very suppose toward lamp, okay, toward LED lamp, and it's a hall area. Okay, so is it possible to illuminate illuminations properly throughout the hall? No, not possible. So it can be illuminated in good maximum 8 cross by 8 foot by 10 foot rooms. Okay, so if you fix it up for 20 40 by 40, okay, rooms fits foots, okay, square foot room, so definitely it is not possible to get that amount of illumination throughout the room. Okay, so based on that area, it's also important. So what is that value? Theta, that lumen actually received on the working plane by lumen emitted by the light source. Okay, that ratio is very important. Okay, for example, okay, the direct lighting. Okay, for example, the direct lighting, the value of n varies between 0.4 to 0.6 and mainly depends on the shape of the room. Okay, shape of the room, type, okay, and mounting height of the fittings, and very little of the color of the wall and the ceiling. Okay, so all those things are very important. For indirect lighting, okay, it lies between 0.1 to 0.35. Okay, so the values are given for direct lighting. How much values of n? That is your zero point 0.6 to zero point 0.4 to zero point 0.6. And for indirect lighting, okay, this is for initially it is for direct lighting. For indirect lighting, that value can vary 0.1 to 0.35. Effect of walls and the ceiling from which the light is reflected on the working plane. Okay, so based on that working plane, it's much greater. Exact determinations of the value of the utilization factor is completely complicated, especially the small room and where light undergoes multiple reflections. Okay, multiple reflections also required. Okay, since light leaving the lamp in different directions, okay, is subjected to different degrees of absorptions. Okay, what are the different degrees of absorption? The initial polar curve distribution has also taken into the account even through the manufacturers of lighting fitting supply tables given utilization factor each type of the fitting under the specific conditions. Okay, so for how to get that one? Okay, so before selection of the light, you have to know their characteristics. Okay, how to get the characteristics from the polar curve? Okay, your data sheet. Suppose you are procuring or some solid state devices. Suppose MOSFET, IGBTs. Okay, so what happened? So we have to first fixing up how much voltage it can be withstand and the current, and what is our required switching frequency. Okay, if all those parameter has matched, okay, so after that we are going to purchase the components. Okay, but how to know their parameter value? From the data sheet. Okay, so in the data sheet everything has mentioned based on the batch number of the MOSFET, based on the batch number of the solid state device. Same thing also happened for in these illuminating lamps. Okay, so if you are going to purchase some specific setup or the fittings of the lamp, so you need to know about the data sheet of that lamps. Okay, how much maximum voltage it can be carried. So voltage current is okay, but most important thing that how much illuminations you are getting from the system. Okay, what is your lumen per meter square? Okay, for which purpose you are going to use? Suppose you are having some standard designing, so is it suitable for your standard designing for multiple applications? Sorry, multiple sources of lights. Okay, is it possible or not? That you need to know. So polar curve idea you should getting. Okay, you should get that value. Now another important factor, depreciation factor, that speed. Okay, so from the name you can understand the depreciation means how many when depreciation happen with your system. Okay, the follows allow the fact. Okay, so it's a ratio. Okay, ratio of illuminations under the actual conditions. Okay, illumination under the actual conditions and illuminations under everything in the perfectly clean. Okay, actual conditions means that in my last class we are discussing about different that sedimentations of the dust. Okay, or placing that unnecessary dust with your fittings. Okay, that may cause for glare, that may cause for diffusions as well as some efficiency of your overall system illuminations. Okay, so that's what happened. Okay, so that is the natural conditions, that is natural conditions. So that P is the ratio between that illuminations under actual conditions or the natural conditions. Okay, when that dust are not clear. Okay, when it is there. Okay, and ratio illuminations, even everything is perfectly clean, means for the perfectly clean conditions how many lumen per meter square is coming from your system. So you are getting a making a ratio, so definitely maximum value can be 1. Okay, more than 1 is not possible. Okay, so that value should be nearer to, should be 1 or nearer to 1. That value degrades means that p value also degrades. Okay, so that's why it is written that factors allows, okay, allows for the facts, okay, that effective candle power of all lamps or the luminous sources, okay, sources deteriorates owing to blackening or the accumulations of dust or dirt, okay, on the globes and reflectors, etc. Okay, so that dust having some effects to the systems. Okay, similarly the wall and ceiling fan also the same thing happened, also do not reflect much light as when they are in clean. Okay, so the value of that factor may be taken 1 by 1.3 if the lamp sitting in likely cleans, or 1.15 if it's having dust. Okay, so if illumination under actual condition, if it is 1, and for the perfectly clean, so definitely it can be 1.3, it can be 1.5. So based on that value you can decide that one. Okay, so next one, what that since that illuminations, here we can see the illuminations is specifically lumen per meter square. The area in the square meter multiplied with the illuminations required in lumen per meter square. Okay, so for what, for which purpose, means how many areas is required for that one, that you need to know. Okay, so you know that flux. Okay, so flux is coming that E cross A. Okay, you know that E is your desired illumination, so lumen per meter square. A is the area. Okay, area for the working plane of the illuminated in meter square. N is the efficiency or the utilization factor. We're getting later. First we discuss that neta value, and P is your dissipation factor, the maintenance factor. Okay, dissipation factor or the maintenance factor. So based on that value, we directly get that flux. Okay, how much illuminating flux is coming from your source. So taking into the considerations under illuminations factor, under the illuminations and the depreciation of the maintenance factor. These two are important. The expressions for the gross lumens are required like that. Phi equals to E cross A by eta into P. Okay, the size of lamp. Okay, the size of lamps depends on the number of fittings which, if the uniform distribution is required, and should not be far apart. Okay, the actual spacing and arrangement is governed by the space per height values and by the layout of beams or columns. Okay, so how much beams and columns are there, based on that you can calculate. Greater the height means the wider in the spread that may be used. Also the larger will be unit required. Having the settle the number of the units required, the lumens per unit may found from the total lumen per number of units. Okay, from which the size of lamps can be calculated. So that's very important. Okay, there is some mathematical equation, calculations. Okay, so you can noting down in your copy. Okay, and similar type of problem you can solve in your home. Okay, so at the time of exam it will come. Okay, so please be taking very carefully. Okay, simple problem, nothing complicated, very simple problem. Based on that formula you can solve it basically what the basic concern about the questions. You have to calculate the number of lamps. Okay, or suppose number of lamps are given, so you have to calculate the number of area you can properly enumerate it by using all those lamps. Okay, 2-3 patterns are there. Okay, nothing more, and simple type of questions are there. Okay, you should practice well in your home. So what is our first example? So it's given, the area of the room is given, a room of 8 meter into 12 meter. Okay, lighted by 15 lamps. Number of lamps also given 15. Okay, to fairly uniform illuminations of 100 lumen per meter square. For one lamp, it is getting uniform illumination of 100 lumen per meter square. Calculate the utilization coefficient of the room. Given output of the each lamp is 100 lumens. Okay, so it's given. What is the formula? Phi equals to EA by N into P. Okay, so directly that lens lumens emitted by the 15 lamps. Okay, for one lamp, how many lumens are there? 1600. For 15 lamps, so 15 into 1600 means 24,000 lumen. Lumen received by the workspace, that given, that 8 into 12, which is already given. Okay, so area A is given and 100 is there for the uniform illuminations, E into A. Okay, that E into A. In last class we discussed, last to last class, we discussed about E into A, that E into A cos phi. Okay, that formula was there, area. Can you recall that? That polar curve I have missed. You can see here. Okay, so I will discuss in my some of the class. Okay, so here you can see that E into A. Okay, so A cos phi. Okay, suppose here we are only considering the A. Is my slide is visible from your end?
Yes, sir.
Here you can see that it is your A. Okay, so into A. So now A is shifted with theta, so only theta will be multiplied. Okay, so simple things are there. That polar curve I have missed actually. Okay, candle power distribution. So it's look like that. Okay, so angle will be there for 0 degree. Okay, so positive side it is writing. Okay, so you can see like the anti-clockwise 0 degree, 30 degree, 60 degree, 90 degree, 120 degree, like that. Okay, so now your point source is there. Okay, you can recall that old studies, suppose diffusion. Okay, so in your +2 level it was there, otherwise first year physics. Okay, so another two properties of the light. Okay, so the particle nature, I think so. It was diffusions. Another one is that polarizations. Okay, so two properties are there. So how vertical and horizontally it is distributed. Okay, so it is your x. Okay, x dash, that lines are there, and candle power, that y dash, y prime. Okay, candle power, that y prime and y plane. Okay, two primes are there, y and y prime plane. Okay, how it will be distributed, that you have to calculate. Okay, so and you can see that light. Okay, so the light source is there. Okay, that is y prime. Okay, it may be connected in x prime as well as y prime. So here you can see initially it was there x prime. So distribution happened in y prime plane. Now that light source is there in y prime plane. So it will distribution is happened in xy prime. So it is a candle power. Simple thing, nothing complicated. Okay, so angle wise it is given. Now how many, there is a meter, 1 meter is there. Okay, to find out the intensity. So from that individual angle we will find out that value, and then you have to plot this graph. Okay, angle wise, that is 0, 30, like that, anti-clockwise 0, 30, 60, 90, 120, 150, 180, then to 110. To 110 means you can write 180 minus 50. So again you can clockwise, one is clockwise and anti-clockwise. So this side, like that. Okay, it should be realized such. This is the difficult to give a graphic representation, three-dimensional model of the plane surface, that you need to find out. Therefore, with the engineering drawing, it is usual to draw in only one or more elevations of the plane. Elevation means front view. Okay, in graphics drawing, I think you can recall that elevation means front view. Okay, so of the plane. the sections show that center so of the source, the elevation of the represent that control power distribution in the vertical or in the horizontal. Two mode of operation can be possible. Okay, so candle power distribution of the source in all direction depends on the shape of the plane. So how much shape? So it is uniformly distributed or the shape of the plane, so it can be distributed. So based on that, you can plot those data. Okay, that's called that polar plots. Okay, so both are there that I am talking about 180, then 210, like that MSCP, MHCP. Okay, then some basic one. Okay, that portion again I will discuss some of the questions. So where was I? That I need to discuss first. So area is given that 8 into 12. Okay, and that how many lumen per meter square, that E. Okay, so E into A. So E into A, you are getting that value is 9600 lumen, and you have already get that value. Okay, so, that utilization factor you need to find out. Okay, so utilization factor is how much? So lumen is given that 9600 for total room. Okay, and that individual lamp given that 1600 lumen. So for 15 lamp 24,000 lumen. So total room means how many utilization factor? So 9600 whole divided by 2400. 24,000 lumens. So it is coming zero point 0.4. So more light is given for that small area. So utilization factor also less. Okay, it should be more, nearer to 1 for getting better factor. Okay, the illumination of a drawing office. Okay, drawing office, that is 30 meter into 10 meter. Okay, is to have a value of 250 lux. Okay, is to be provided by the number of 300 watt filament lamp if the coefficient of the utilization is zero point 0.4 and the depreciation factor is given that zero point 0.9. Determine the number of lamps required. Okay, which values are given? Phi. Okay, phi equal to E into A whole divided by eta into P. So E is given 250 lumen per meter square. Here it is given lux. Okay, lux means lumen per meter square. 250 lumen per meter square is given. Okay, then A value, what is your area? That is 330 meter into 10 meter. So you are getting the A value here. So 300 meter square. So N value is given zero point 0.4. Okay, that's utilization factor 0 point 0.4 is there. Depreciation factor is there 0.9. So automatically you can find out the phi. Phi equal to how? 250 into 300 whole divided 0 point 0.4 into 0.9. So it is coming 208. 333 22 lakhs 8,333 lumen. Okay, efficiency of the lamp is given 15 lumen per watt. So how many specifications? Okay, total how many numbers of lamps are required for getting, so divided by this number by 13, so it is coming 300. Okay, so sorry, 300 lamps are phi is given what? Phi is given, that area is given 300. Okay, so 300 is there directly. So you are getting that efficiency of the lamp is 14. Okay, so 300 into 14, you will get that flux emitted by lamp. So from here, okay, directly you will get it. Okay, so number of lamps you are also getting. So fractional order is not possible. So next one you should consider. Okay. So next one previous one. So what you have to manage it by that calculations. Okay, I hope you are getting that idea. So next problem. Okay, you just noting down that problem. Find the total saving. Okay, find the total saving. You solve it in your home. Okay, so find the total saving in electrical load and percentage increase in illuminations if instead of using 12 150 watt tungsten filament lamps, comma, we use 1280 watt fluorescent tubes. Stop. It may be assumed that number one, there is a choke coil, okay, choke loss, choke coil loss actually of 25% of the rated lamp weighting wattage. Number one. Number two, average luminous efficiency throughout life for each lamp is 15 lumen per watt. For each tube, 40 lumen per watt. And number three, the coefficient of utilization remain the same in both cases. So that you need to find out. Okay, so I have that solution is already given here. So any doubts are having, so you can ask me. First solve it in your home. Okay, so if you're facing any doubts, then ask me, no problem. Okay, and try to solve by yourself. Okay, that's a not so much complicated problem, simple problem. Okay, so if you practice well manner, so there is no problem for getting good score. Okay, by default, most of them are getting good marks. Okay, but you have to give write all those things. Okay, your exam should be good and presentation must be impressive, required impressive. So that's only way to get to score good marks. Not like only these subjects. It can follow by every and every subject. Some of the person they may talk about it, some of them are not. So presentation is very important and the practice, numerical practice are important. Okay, solve it to your home. Okay, so next one, these 2 points I will discuss in next class. Okay, some portions are there still there and some vapors, lamps and different properties of lamps are there. You can take a screenshot also for getting the calculations. Okay, so solve it. Okay.